Hello. In this lesson, we are going to learn about calorimetry. 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 What is calorimetry? It is all about measuring calories. However, though, in this lesson, we will be more focused on using a calorimeter. Do you remember a calorimeter? Okay, some of you must have already used a calorimeter, solution calorimeter. So, we are going to learn about the principles of calorimetry and mainly how to use a calorimeter. Calorimeter. That's what we are going to look at. Okay. Now, some of you might have found calculations related to calorimeters are difficult because there are so many temperature change and calibration factor, that sort of stuff. It can be a little bit confusing, but if you can understand the basic principles, it is not going to be difficult. Is that clear? It is not going to be difficult. All right, let's give it a go and see whether we can understand this stuff. Okay. Now, firstly, in chemistry, we don't measure energy directly. I mean, if you want to find out the energy that get released during a chemical reaction or delta H of a chemical reaction, we cannot measure that directly. Instead, what do? We measure the temperature change. We measure temperature change, then we translate that temperature change into heat change. That's what we do, all right? Now, let's look at what we've been doing so far in our lessons. Do you remember when I asked you to find out the delta H of a particular fuel, or in other words, what's the enthalpy change when there is a fuel get combusted? So what did you do? Do you remember what you did? Probably you did that in a school setting as well. You had what? You had a spirit lamp. Into the spirit lamp, what did you do? You put fuel. Now what are we trying to do here? We are trying to find out the enthalpy change during the combustion of this fuel, or enthalpy change during the combustion of this fuel. So as example, let's say this fuel is ethanol. If you had ethanol as a fuel, now if you want to find out the heat of combustion of ethanol, what do you need to do? Experimentally, I was meant to say, you need to burn it. So when the fuel is burnt, what will happen? It's going to release the energy. That is the energy what we need to measure. However, though, we cannot directly measure that. In order to measure that, we need to measure the temperature change. Then you might be thinking, what? Are we going to put the thermometer into the flame and measure the temperature change? No. I mean, if you put the temperature thermometer into the flame, there is no temperature change. You will get a constant temperature if you can measure it. Instead, that method is not going to be accurate. Instead, what do? Do you remember? We get a beaker full of water. Not full of water. With certain amount of water. Then what do? What do we do here? We heat up the water. So what are we pretty much doing? We are trying to transfer the energy, which is Q fuel, we are transferring into the water. Or in other words, we are pretty much getting the water to help us in absorbing that heat, because water is going to capture that heat for us. So in other words, we are sending it into the water, it becomes Q water. Q water. So then we made an assumption that Q fuel is going to be equal to Q water. But we know that this is not correct. This is not correct. Why this is not correct? Not all the energy from the Q fuel is not going to go into the water. In a real life, that is not going to happen. We know that. We know that. Because some of the energy from this fuel, Q fuel, some of the energy is going to be lost into the surrounding. There will be energy lost. So some of the energy, we say Q lost. Q lost. Some of the energy will be lost into the surrounding. Not only that, some of the energy will be used to heat up the can as well. The can is also, or the container is going to absorb some of the energy as well. So we say Q can. Now, as I said to you before, Q fuel is not just Q water. We can make a more accurate version of that expression. We can say Q fuel is going to be equal to Q water plus the Q can. Oh, there's a thermometer as well, because we need to measure the temperature change of the water, which I forgot to mention that. And you have to make sure that you have to have a stirrer as well to stir and stir and stir before you start making that temperature change. You need to make sure the heat is evenly distributed. So it's not just Q fuel is equal to Q water plus Q can plus Q stirrer plus Q lost. Q lost. Now, this expression is going to be more accurate than this one. This is wrong. In real life, it is wrong. But we did not have any other option, did we? Because at school, we only had this primitive setup. So we had to use that. So Q fuel is equal to Q water is not an accurate expression. Because in this method, we are not going to consider the heat that get absorbed by the can, the stirrer, and the heat that get lost to the surrounding. We don't consider that. Do we? Do we consider that? No, we don't. So what can we do about it? What can we do about it? By the way, if you are going to stick with this method of measuring energy, you know that our delta H value, experimental value, going to be much lower than the accurate value, or we say theoretical value, because of the heat lost. Is that clear to you? Now, if you are not sure, you remember how to find the Q fuel. Q fuel is equal to the, delta H of the experiment is equal to the Q fuel divided by the number of moles of fuel. So we know that at this stage. Now, going back to this. So if we can contain all that energy that is going to be released by the fuel into a one place, we will be able to get an accurate delta H value. Or in other words, we will be able to get accurate Q fuel value. Accurate Q fuel value means accurate delta H value. So that is why we use a calorimeter. We use a calorimeter. It's a special type of a container. Calorimeter. We do the reaction inside this special type of container. By doing that, we are not just going to say Q fuel is going to be equal to Q water, we are also going to incorporate Q can, Q stir, Q everything, including the Q lost. That is why we use a calorimeter. So by using a calorimeter, not only that we are only going to use Q fuel as Q water, but also that we incorporate these Q values, Q can, Q stir, Q that, Q this, everything into this expression. Thereby, what do we do? We can get an accurate Q fuel value so that we will end up getting accurate delta H value. That is why we use a calorimeter. That is why you use a calorimeter. Is that clear to you? That's the first thing you need to understand. Now, if the VCA this year going to ask you, what is the whole purpose of using a calorimeter? Simple answer is, by using a calorimeter, we can get an accurate value for energy that get released by a chemical reaction by minimizing the heat lost, but also incorporating the heat that get absorbed by the other parts of the calorimeter. Parts means the walls of the calorimeter or the component of the calorimeter. The stir, that is also one of the component. So we are going to incorporate these values that get these heat absorption values into Q fuel. So you are going to get a more accurate Q fuel value, which in turn will help you to get accurate delta H value. That is why we use a calorimeter. Now in my next lesson, let me teach you what is calibration of a calorimeter means to you. Then we will be able to do questions related to calorimetry. Now I really want you to understand why we use a calorimeter. The question, answer to that question, why we use a calorimeter. Hope that is clear to you. See you soon. Bye.